So the title of this talk is Building Tiered Cloud Storage in Azure. It's really about our Azure storage platform and specifically the object storage. And when we're talking about tiering, we'll weave that in through the talk. It's really referring to tiering from on-prem onto the cloud, as well as tiering within the cloud. And we'll talk about both of those patterns through the talk. So we'll start off with a brief introduction to Azure Storage. There's a talk prior to this that'll be recorded and available that goes into more detail on the overview of storage. But we're going to spend most of our time today on the object storage system, which in Azure is called Blob storage. So if you ever hear the term Blob, which is a funny term, it refers to our object storage platform. We'll talk about key concepts, architectural design, and kind of how we built the service and how you can use it. To give you some sense of kind of getting started working with it. And we'll cover a few design patterns that come up again and again in terms of how you can think about leveraging Azure Storage and Blob Storage in your applications, or when you're using it as part of a solution. And since there's always going to be a mix of folks that code directly to Blob Storage, as well as people who use Blob Storage for things like backup and DR, in hybrid storage, we're going to have a set of excellent customers and partners that will come up through the talk and talk about how they implemented and used Blob storage in their scenarios. So let's get started. The first thing I want to kind of go through really quickly is this set of talks. This is the second in a series of 4 talks from our team. The first talk just concluded a little bit earlier. Some of you may have come from there. It will be on Channel 9, I think, within the next day or 2. That goes into a little bit of a higher level overview of storage. What are the cost benefits? What are the different solutions that we can implement? So we won't cover that as much. As we said, we'll go into object storage. In terms of our other services, there's a talk tomorrow that really goes into our single instance block storage that you attach to VMs, and our shared storage, SMB storage that you attach to VMs as well, called files. And lastly, because data security is something that's very important to all of us, we have a different session on that on Thursday that covers topics like having Azure Active Directory on the control plane. How do you secure data? How does data encryption at rest work? And more deep dive topics around security. So we always start our talks with this slide. This is from the Azure Regions page. And the reason we start this this way is storage is a pretty fundamental part of our platform. It is the distributed storage layer of all of Azure. Right? In order to bootstrap a new region, we must have 3 services running for our own infrastructure services to come up. That's compute, networking, and storage. So those are the key pieces. There are 34 regions total, 30 of them running, 4 of them announced, and storage is available in every single one of these regions. It's also a fundamental building block of all of the remaining Azure services. Every Azure service, directly or indirectly, stores their data in Azure Storage. So you look at services like all the data services, the big data analytics services, the streaming services, the IoT services, all of that data, while they expose different APIs on top and different functionalities, different convenience, caching, other things, fundamentally persistence of the data is happening to the Azure storage layer, and specifically the Azure object storage layer usually. Also, many of our Microsoft services on the commercial side, things like Office 365, all of the data there is stored in Blob storage. Services like Xbox, Skype use Blob storage, tables, queues heavily to build their services. For example, you can't really boot up an Xbox One and connect it to the internet and play your games without the Azure storage service being available. So the storage service has a set of characteristics or capabilities that we like to talk about. The first one is hyperscale. So let me put some sort of color around that term because it's a often used term. One way we talk about it is the fact that we have over 120 trillion objects and over 19 million transactions per second to our platform. Another way of thinking about this, let's say this in the next hour that we're spending together, an hour and 15 minutes, we will have about 6 billion net new objects added to our system. We will do about 2.5 petabytes of ingress and egress in that hour. And we will do almost 60 billion transactions off of that data, right? You add that up over a year, and the numbers are truly staggering. We're talking about hundreds of trillions of transactions. We're talking almost 22 exabytes of data coming in and out of our system. So the numbers are amazingly large, and that growth curve is still accelerating. So it's not a linear growth curve where it's sort of doubling over time. That slope is still exponential. We're also a durable platform. We make the promise to never lose your data. We keep multiple replicas of your data. We respond to all forms of hardware failure. And we also do constant scrubbing of the data for things like bit rot protection. So we're constantly reading the data, doing checksums, correcting any corrupt copies that happen due to bit corruption, and storing it back. We're secure. We have encryption at rest. We also provide great helper libraries for application encryption. We're highly available. So any form of disk, node, or rack failure will automatically recover from. So you don't really have to worry about it. As an application accessing the platform, you don't notice that more than a little blip perhaps every now and then. We also do automatic load balancing. So if you have a set of blobs or a set of table entities that are sitting there, and suddenly you have 1 million visitors kind of try to come and download that object, we will notice that traffic and will dynamically scale out and start serving that object over hundreds or thousands of servers, and then scale back down automatically. So that's something that's part of the service. We're also pretty platform agnostic from a client-side perspective. We have a REST API that you can code to that's open and fully documented. But we also provide client libraries in a number of platforms. .NET, of course, but Java, C++, Python, and the mobile platforms, iOS, Android. We have a great Xamarin library for cross-platform development. So all of these things, our goal is no matter where your data is, no matter what kind of application you're building, we're able to get your data from and to Azure Storage. And lastly, we are one of the cloud providers that really have a great hybrid cloud story, right? We have an extensive partner ecosystem. You'll hear about some of those partners today, but we really kind of take pride in knowing that we can't go at this alone. We have to do it in partnership with our partners, our ecosystem, and all of you, working to work with us, build and integrate Azure Storage in. We have our own first-party services, of course, in things like Azure Backup, Azure Site Recovery, Store Simple, that all connect in one way or another to Azure Storage. And lastly, with the Azure Stack, which you heard the announcement from Scott yesterday about going into technical preview 2, we have a fully API-consistent implementation of all of our services in Azure Stack. So in the cases where you cannot store your data for sovereignty or data residency or any other regulatory reasons, you can still have the exact same code base work both against the public cloud and your private or hosted cloud. So what services do we offer, right? And one of the ways to think about this is, the oft-mentioned IaaS and PaaS world, where you're either running your own infrastructure or you're using higher-level services. On the infrastructure world, we provide disks and files. Disks are single-instance disks that are attached to VMs. Files are shared storage over SMB. Both of these are provided as a service to your VMs. And then, as I mentioned, there will be a detailed talk about that tomorrow. And we have objects, tables, and queues on more of the PaaS side, or stuff that you'd either need to use a partner to plug into it, or you'd be writing code against those services. And objects, we'll talk quite a bit more about in this talk. Tables, we won't be talking about at this conference, but there are talks online on Channel 9. Tables are our massive NoSQL store, basically. So if you have a lot of key value data, a good example is Xbox Live with all their lists of gamer tags and saved games and sort of achievements, history, things like that. That's sort of key value data keyed off of your gamer tag or gamer ID. For key value data, this is great. It can scale to hundreds of petabytes of data, and it's a good thing to kind of go look at if you have the key value data that you need, either a very highly scalable or a very cost-efficient service for. Queues are our intra-service and inter-service communication mechanism. That's also something that's very often used when you're building PaaS services on top of Azure. And all of these services, as we talked about, are built on that common unified storage system. So all the capabilities we talked about on the previous slide are available to all of these services. One thing that I want to dive into in particular is durability, because for a data platform, durability is everything. If you don't have that, you don't have a data platform. So as I said, we start with the distributed file system layer, dealing with failures, dealing with checksums and CRCs and all of that in the background. But another interesting characteristic for us is basically what we call strong consistency, and that's read after write consistency. When you write the data, when you write the data to our platform, we write it to 3 different disks on 3 different racks, and we only act the write back when the write has been committed to all 3 copies. So if you have an application that's writing and then other applications are reading, you never have this eventually consistent problem that some cloud platforms have. So in terms of redundancy options, we start with what we call LRS, or locally redundant storage. So that is the 3 replicas, 3 disks on 3 nodes on 3 different racks in a single region. And that protects against failures at that level. And this, the side effect of this is you don't really ever have to think in our platform about things like RAID, even for your VMs and shared storage. You don't have to think about traditional forms of backup. Now, you still need backup if you're trying to do other things, but the traditional forms of backup where you're trying to protect against hardware failure are not necessary. Stepping up from there, if you need your data to be resilient against major regional disasters, hurricanes, floods, meteorite strikes, whatever, we do offer automatic georeplication to another region hundreds of miles away. And that is an asynchronous process, unlike the first one that's synchronous and strongly consistent. So within a couple of minutes, we will replicate that data to another data center. If you want to use that second copy for high availability, we provide a service called GRS, which is read access. So you get a secondary DNS endpoint for that secondary copy. You can query the replication lag so you know what your RPO is for your application, and you can use that secondary copy as needed. So let's dive into object storage a little bit more and kind of get going there. So let's start with what the Blob storage service really is. It is a service to store and serve unstructured data, right? Any kind of unstructured data, small files, large files, from a few bytes to a few hundred gigabytes. Typical use cases are app and web scale data. So if you have mobile apps out there, if you have websites and you're doing very, very high scale services, you can use this. Big data feeds incoming from things like your IoT sensors and IoT devices, or in industries like genomics, where sequencing a genome can be, for a single person, can be terabytes to hundreds of terabytes of data. And our more canonical thing in our world today is backups and archive, right? Backups and archive is a growing problem in enterprises, and it's not cost effective to put it on very expensive on-prem storage than deal with retiring that hardware, migrating that hardware. So this is a great use case for that. We talked a lot about these features. As a customer, you can store petabytes to tens of petabytes to hundreds of petabytes of data. Scale is not a problem. We talked about durability. In terms of availability, we have 3 nines SLA, 4 nines if you're using the GRS. We talked about consistency and scaling up. So the last point I'd like to make there is the cost effectiveness, right? When you look at especially services like cool storage, which we'll talk a little bit about later in the talk, this can be a very cost effective thing. When compared to on-prem costs, starting with the raw array costs and then stepping up to your service and support, your under provisioning for having to grow into an array, your migration time period where you're buying a new array and all of that, the total cost of ownership is typically much lower in cloud storage. So let's start with a scenario. We always say, well, blob storage is ideal for PaaS, right? And I showed you that diagram when I put it under the PaaS umbrella. And the question is why? If you're building an application, why is that the case? three things mainly. Again, cost efficiency, of course, but the second thing is limitless scale, right? Not having to worry about provisioning for your application is a very beautiful thing. As an application developer, you can focus on your application code and know that whether you need a terabyte of data or a petabyte of data, and even if you don't have an idea up front when you launch your app, you're going to be okay with us. And globally accessible is another interesting point as an application writer, having the ability to deploy to where our users are, right? If you're part of an enterprise that has a global presence, or you have customers that are globally present, you can have your data where the customers have much lower round trip times, have a much better experience for those customers. So there's a set of scenarios in terms of using Blob Storage for live data, using it as an active archive or as a big data analytics store. But rather than kind of bore you with theoretical scenarios, I thought we'll have a customer come up that's built on top of Azure Storage and really talk through how they used Blob Storage for their scenario. So it's a show of hands, how many of you have heard of or seen an ad for CarMax.com? Okay, so quite a few of you. So I'd like to welcome Brandon Linton, who's an architect at CarMax.com, to talk about how they use Blob Storage.
Thanks, Vamshi. All right, so good afternoon, everybody. Quick show of hands. How many of you are part of some sort of on-call rotation? Okay, pretty good number of you. How many of you just love it when you get called, playing with the kids, dinner? Okay, no hands in the room. Okay, so my name is Brandon Linton. I'm a solution architect on CarMax.com, the online systems platform team. And today I'd just love to share with you a couple examples of how we've leveraged Microsoft Azure and specifically cloud storage to improve the availability and capability of our systems, hopefully give you a few ideas of how you can improve your own, maybe get called a little bit less. So first, I'd like to jump over to CarMax.com. So this is our homepage. For those of you who might not be familiar with CarMax, we're the nation's largest used car retailer. We've got over 160 stores nationwide. But right now, we're going through a digital transformation where really everything's changing for us, and we're moving into more of an e-commerce space. So there's a ton to do on the site. We recently completely redesigned and replatformed the site, but I'm going to jump right into search listings and find a car. And the first thing you'll notice as these load is that we've got a ton of real estate dedicated to vehicle images. And we've spent a lot of time and money on this because we know customers love these images. We know that when the vehicle doesn't have them for whatever reason, the cars just sell much less quickly. And so it's really important to us to make that really good and really prominent. You can see here there's an image slider utility where I can engage with them before I jump in. But of course, I'll dive deeper into the car itself. And on this page, again, there's a lot to do. One of the most exciting things is that you can hold the car for free, which is great. But again, really, first and foremost are all these vehicle images and the ways that you can engage with them. And so I've actually pulled up one of these pictures in a separate tab just to show you that this is actually coming from a separate website altogether, img2.carmax.com. And up here is actually the width.jpg. So I can make this any arbitrary number, and it's going to scale to that. And the really nice thing about that is we're actually a fully responsive site. So if I pull this down, got a little lost. This is fully responsive, so it's going to scale to match the user's resolution. And so having dynamic resizing really helps us deliver the right image to the right device at the right time. But it wasn't always this good. So about 3 years ago, we weren't in the cloud at all. And so I'm going to discuss a little bit about our original images architecture. So basic process was at the store associate would take pictures all around the vehicle, would use a custom desktop uploading application to submit those to our team's suite of image services. And that would do a couple of things. It would upload to this image sand. So this is really about static resizing. We'd get 6 different sizes of the images and put them there. And then we'd also log all of those URLs because they weren't really guessable. They weren't any convention. So that applications could pull from that database, serve them up. And then there was just a very simple static file handling IS site that sat in front of that. But that had 3 really big challenges. The first was capacity. So that image SAN was a fixed size, and we were about to hit it right about the same time we wanted bigger, better, higher quality photos. So that was painful, so we frantically tried to compress those images to make sure we didn't slam into the wall. We tried to spin up another fixed size SAN, but that was taking a lot of time. Copies were taking hours. And we also tried to spin up another SAN, another data center, and copy that over, but of course that was taking days. So none of these were really working for us. And we didn't have the capacity to pull off dynamic resizing at this point. It was a very CPU-intensive operation. So we looked around, and really Microsoft Azure and Azure Storage were the answer to all of those challenges. Everything pretty much remains the same here, except we upload the original image straight to Blob storage. And so this solves our capacity problem, because as Vamshi mentioned, it's basically unlimited scale. So I think we've tripled the size of our original image SAN, and we didn't even know it. I had to look that up before this talk. To get high availability, well, we just enabled read access geo-redundant storage. So within a couple of minutes, those images replicate right across to the east region from west. Those are in sync within a couple of minutes. And it's really powerful because we know we can always serve up images from either data center. And then to handle the dynamic resizing for all these different devices, all that traffic comes through Azure Traffic Manager. And that gives us the ability to route intelligently and also shift all the traffic to one region if there's some sort of a problem. So that's really powerful to deliver the right image to the right device. And then when we went to that site redesign and replatforming project that I mentioned, it just made total sense to move our entire web tier into Azure and get a lot of the same benefits. So we're active for CarMax.com. We're in 2 regions, East and West US. We didn't do kind of a traditional lift and shift. We actually targeted all these platform as a service offerings. So cloud services, SQL Azure, and Azure Redis caching. Caching is one of my favorite because, as a web team, we talk forever about having a distributed out-of-process cache. And I don't know if many of you have got a lot of problems provisioning on-prem and just the time that it takes to get all that spun up. Who can run these things operationally? But that was certainly our problem. And in less time than it took me to explain that problem to you, we just provisioned it in Azure. We went to the portal, we clicked Add New, we used resource templates, and it was a huge win for our performance and availability. But we didn't rewrite everything, so the on-prem services that we have still that we reach back over to, we achieved that through application request routing, which is a reverse proxy technology, as well as Express Route, which is in the works. So what's next for vehicle images? So because of that limitless capacity we talked about, 360-degree photos, videos, these are all things that are options that are available to us now. So we're going to invest in that. We're also leveraging the image metadata that comes from the cameras at the store to start to be able to group photos by exterior and interior images, which is really powerful. And then finally, we have an owner's application. This is newly launched that allows past purchasers to register their vehicles, that they've purchased them, and then kind of own the entire ownership experience. It would be great to offer the high-quality pictures that we took of those cars early on. And so we're going to look at moving those into cool storage, so leverage even more cost efficiency. And finally, for teams, all this technology has been a huge cultural shift for us at CarMax. We've got these cross-functional product teams, product owners, lead engineers, lead user experience designers. And we just want to continue to leverage those great benefits to peel apart some of those bigger services that you saw so that they can have their own highly available microservices and innovate quickly on those. Finally, if you're ever in the Richmond, Virginia area, this picture in the background is our new digital transformation space. And we'd love to have you come by, talk about architecture, come visit us sometime. So thank you.
Thanks, Brandon. Well, thank you. That was a great example of a real customer scenario using Blob storage, but also using all the different services in Azure to make that transformation from an on-prem service to a much more scalable, modern application architecture. So thanks again, Brandon. So with that, let's kind of switch gears and go deeper and peel back the covers and look at how you can use Blob storage. What are the different architectural things that you can do? What are the key concepts? So let me start with the fact that there's 3 kinds of blobs. The first one, and probably the one you'll use the most often, are called block blobs because you store data in blocks. and we'll get into that in a little bit. This is where you canonically put your data. If you just use our client libraries and you store data, you're using the block blob, and you'll see something called the block blob interface in every client library that you open up. So you can use it to store all kinds of unstructured data, again, from small to very big. We also have another kind of blob that's less frequently used, but for those who need it is very critical, which are called append blobs. So they're very much like blobs, but they're optimized for multi-writer append scenarios. So you can think of things like MapReduce jobs where there's lots of writers trying to append output data. You can think of log file writers, right? You have 1,000 machines that are all trying to write logs. You can have append blobs function as a really good append scenario where you don't have to sort of lock the blob in a way, or you have issues with inconsistency or concurrency issues. So we won't talk about append blobs much more in this talk, but they do exist. The other kind of blobs that are also interesting, if you have specific scenarios, are called page blobs. Page blobs are big sparse files in which you can put pages of data, right? You can treat it effectively like a disk. You can read randomly into that page blob. You can write randomly anywhere in that page blob. And we actually built this type of blob to underlie our disks implementation for our VMs. So this is what underlies every disk in our world is a page blob. And we built this and said, hey, there's actually customer scenarios where we should expose this externally. So we have a REST API for page blobs, and a bunch of our Azure service teams use it. For example, the Event Hub service stores data into page blobs to make some of their access scenarios faster. We have external storage partners, especially, who do kind of efficient deduplication and kind of matching up to their architecture of understanding disks that use page blobs as well. So all of these types exist. For the rest of this talk, we're mostly going to look at block blobs. So again, zooming out, let me look at some key concepts for blob storage. The first notion, as many of you are familiar with, is the notion of a subscription. Every Azure account, you have an account with Azure, you'll have one or more subscriptions. Within the subscription, you can create one or more storage accounts. Storage accounts are just logical containers for your data. Today, you can put up to 0.5 petabyte of data in each storage account, and you can have up to 250 of them, though really you can have as many of them as you want. If you're a customer who needs more than 100 petabytes of data, that's not an issue. We just put some kind of logical cap on it so you can think about them that way. Every storage account has this notion of a container. So object storage systems don't have traditional directory hierarchies, right? They're pretty much flat file. You have a name. But we added one layer of folders, if you will. So one layer of top-level directories, and that's what containers are. So you have your account, and then you have containers. You put your blobs inside containers. You can, of course, put it in the root container without any container if you'd like. And every blob has sort of a URI with your storage account name, .blob.core.windows.net, with your container and your blob name. So let's switch over and take a look at how this actually looks in the portal. So let me bring this portal up. You see this is my personal Azure account. And I can go ahead and click New, Storage, and Storage Account. I can go ahead and say Ignite 2016. And that's already taken, so let's add my initials. That works. So you'll notice that we have both the old Classic and Resource Manager. Unless you know you need Classic, we'd recommend you use Resource Manager accounts. They give you a lot of flexibility in the Azure resource model. You'll notice that there's a general purpose and a blob storage account. Typically for blobs, you would choose blob storage account because that also gives you the cool tier that we'll talk about. Blob storage today is only standard, so you'll see that. You can pick what kind of replication. I'll go ahead and pick locally redundant. That looks like a UI bug. And then we have this notion of an access tier, cool versus hot. And you can basically switch this at account creation time or any other point during your account ownership or account lifecycle. Another thing here with encryption at rest, you'll notice it's just a little checkbox. Just like that, I've sort of said, hey, I want to use encryption at rest, and all my data coming in is going to be encrypted. Pick a subscription. I'll use an existing resource group and see if that works. May not have one, but let's just create one. Ignite. That's fine. And I'm going to create an East US 2, which is our data center in Virginia. I'll go ahead and pin this to dashboard and click create. You can, of course, do this without ever coming to the portal through PowerShell, through command line interfaces on Linux and Mac. I'm just showing this to you in terms of being a little bit visual. So while that's creating, let's take a look at an account I'd created earlier yesterday. And the interface kind of looks like this. You can see the endpoints that I'm talking about here with the blob.2 core. Because I created this one as a read access GRS, I also have that secondary DNS endpoint that we talked about. We can see that the location is in East US 2 and the secondary, which is why you see that comma, is in Central US. And so that automatic geo-replication is happening, right? So you can go ahead and look and see that there's a couple of containers that are here. I can click on them, and I can see that there's a file in there. And from the portal, if you'd like, you can actually just download, or you can look at some properties here in terms of, yep, it's a block blob, it has a certain size. We'll talk about some of these properties, but you'll notice you have some standard properties like the e-tag, the MD5 checksum to validate that the data is good, and the URL. So that's kind of one way of looking at it, and you can go ahead and download that if you'd like. That just brings up the image if it's a JPEG and the browser understands it. This, by the way, is Eastern Washington. It's called the Palouse region, a very, very pretty part of our state. So let's look at that in the portal, but let's also take a look at something that we have called storageexplorer.com. If you go to storageexplorer.com, that's the Azure Storage Explorer. It's a free tool for Mac, for Linux, and for Windows that you can download and install. I've already gotten it running, and I have the same sort of thing here. I have my subscription. I have my storage accounts in here, and then I can go ahead and go browse containers. So let's look at this demo container blob. It shows me that stuff. I can look at the same test account and see what I'm doing. I can do things like upload a folder. So let me go ahead and see if I can get that to work here. And let me select this folder, which I downloaded from OneDrive earlier, and upload that. And you'll notice that one of the things that's happening is it looks like there's a folder there. And you might be saying, hey, you just told me there's no folders. This is a virtual folder architecture. So we've embedded the folder name as part of your object name. So it's still one top-level container, but I can kind of click in here and treat it like a folder, and that works just fine. And you can see that I can go ahead and click, and it'll open up the image. This is a picture I took yesterday at the keynote. We were way up in the nosebleed seats there. But you can see that you can pretty much use it like a little explorer tool, visually walk through your storage accounts. If you have a little bit of data, you can upload it and things like that. So it makes it easy as an administrator to take a quick look at your accounts. You can also do a bunch of the security features around, kind of generating shared access signatures and the like from this tool. So it's a nice tool worth going and checking out. In this space, we also have a number of partner tools that are also great. We have Azure Management Studio is one. There's a web-based one called Cloud Portum. There's another one from Cloudberry Labs. So there's a number of different, paid and free tools that we work with them pretty closely in terms of having the right user experiences here. So let's also take a quick look at how this looks like in code. And the first thing I would do before I show you this project is if you're trying to get started playing with it, if you install the Azure SDK and click New Project, which is what I did, you have a thing under Quick Starts, under Data Services, where you can create a project for blobs, files, queues, or tables, and get some sample code to get you running very quickly. That's really all I've done here is create a new project with that, and I've commented out a couple of lines of code. And the only other thing that I've changed on this sample is added in account information for that account I created yesterday. So you'll notice I'm not using the local storage, which you can use if you'd like. We have a local development environment that doesn't connect to the internet. But when you're ready to test against the internet, you can just put in your storage account information. So let's go ahead and run this. And all this application does is it goes ahead and uploads a image to this container. So let's go ahead and click that. And that's done. And back to the Storage Explorer, you can see what I was playing with was this demo container blob, and we just uploaded this image of one of the Azure PNG, I guess. So pretty easy to work with, pretty easy to get going. And if you look at the operations here, the blob storage operations, it looks very much like, hey, here's my storage account, here's my blob client, here's my container, and here's my blob, right? So again, you'll notice the references to blobs, which is what we were just talking about, right? So very easy to get started, worth trying out, just takes a couple of minutes to get going and play with the sample code. So let's go back to the deck. We walked through that. We walked through a lot of this in the tool, so I'm not going to spend a lot of time. You have that account name, container name, and the virtual folder structure. That virtual folder structure can be as deep as needed. There are certain limitations on each of these things. The blob name can be up to 1 KB, so you can have as many folders in there as you can fit into 1 KB, and they're all virtual directories, though. There are some convenience features that I'll mention, but they are virtual directories. We looked at some of these properties on the portal. Let me spend a little bit of time on these. Obviously, you have the blob type. You also have this notion of last modified timestamp, which is very useful to check when the blob was last modified. It's also useful for some of the conditional concurrency stuff we'll talk about. And there's also this element called etag, which is this opaque string that changes every time somebody changes that blob. So it's a very easy check if you're caching something. Hey, the etag changed. Somebody must have modified this. And you have the length and the MD5. The MD5 is used for checksumming or uploads. You also can put in a bunch of user-defined metadata, so up to 8 kilobytes of name-value pairs that go with that blob. So if you have metadata, you can embed it right with the blob. You don't have to go use another SQL store or table store if it's just a small amount of metadata that lands with each blob. The advantage of this, as you'll see in a pattern, is you can run full-text search on just the metadata or just the standard data and have a very rich way of getting to your blobs. You can have up to 200 gigs of data per blob, as I said, small to very large. And let's look at uploading block blobs, right? Specifically, put blobs. Put blobs work well. It's the one single call to get you into our platform. Any size of object less than 64 MB, you can just make a single call. It'll go up, it'll put it there, and you'll be fine. It's an override call, so if you call put blob on an existing call, it'll wipe out that object and assume that you wanted it wiped out. For anything larger than that, let's say a large movie file or something, we split the data into chunks of data. That's where the name block blobs comes from. Into chunks of up to 4 MB data. They don't all have to be the same size. And then we start uploading them in parallel. So we give them a block ID, and you can start uploading them in parallel with these put block calls. So you can upload them in any order you want. You can upload them in parallel, so you can get a lot more throughput, because round trip time is usually a big determinant of how much throughput you can get on a blob. And when you're done uploading all your blobs, you can call one API put block list and finalize the blob, right? So that's the call that really says, okay, all my chunks of data are uploaded. Now I'm coalescing those chunks into this distinct blob. That has a couple of interesting side effects. One of the neat things that we allow is we allow intra-object deduplication. So if you have the same chunk of data reoccurring in your blob, you can only upload it once, pay for it once, and then reference it many times in that put block list call, and that works just fine. It also allows something very cool, which we're the only object storage platform that does this. We allow you to change block blobs. This is huge when you're dealing with very large files. You don't want to re-upload your 100 gigabyte blob when you changed a few hundred MB in there. So if you architect your application right, you can pretty much say, hey, I upload only the changed blocks of data. Then I put block list. I can reference old existing blocks and new uploaded blocks. And you can coalesce them and make one single large blob, which is a editable blob effectively. In terms of downloading blobs, Get blob works as you'd expect it to. You can go call it, and it'll all come down to you. Range reads are supported, another interesting thing. Large blobs, you're streaming them to somebody, you're getting a chunk of a blob. You can go say, here's my offset and the byte range that I want to read. You can read chunks in parallel. Again, if you're trying to implement a high-speed parallel downloader, that works great within blobs as well. You also have this notion of copy blob. Now, why would you need that? Normally you can certainly download the data and upload it, make another copy of it. That works just fine. You can do it synchronously. Not a great solution, again, with large blobs. So we built an asynchronous copy blob that you can call the API. It's a single atomic call, and then we will asynchronously copy the data over. We'll give you a copy ID, and you can check the status of the copy. The place where it's really cool is within an account. Right? Because we are referencing all this stuff in our distributed file system, when you create a copy of your blob within your own account, the copy completes instantaneously because it's just a reference count for us. Right? So you've called copy blob, we've created a new reference, and we take care of all the ref counting for those blobs. Really neat if you're trying to make virtual copies effectively of large blobs. But you can copy to other accounts, which will be a little bit slower. You can also copy from external sources. So any HTTP endpoint data, you can copy in. So you can give us the async call. Our servers will go out and fetch the data from anywhere, including S3. I talked also about list blobs and the convenience features with virtual folders, right? So list blobs is a container level operation. So you have to give that top level directory. You can get up to 5,000 blobs at a time. But what's neat is you can essentially have a begins with query. So if you know the pattern of your blob names, you can say, give me all the blobs that begin with this thing. You can also go ask and say, give me all the prefixes with this delimiter. So let's say / is your folder delimiter or any other delimiter. You can say, give me all the prefixes that have / in them, and we'll give you back a list that with basically your folder tree hierarchy with your virtual folders, and you can go in and get just that set of blobs. That's actually what the Storage Explorer is doing underneath the covers. When I click on the folder, it's saying that's the prefix. Let me go get it. Delete blob works the way you'd expect it to. The reason I have that up here is the other nice feature of containers is it's an atomic operation on the container. So if you have a container with 100 million blobs, you can just delete the whole container if you're done with that container. You don't have to go in and call delete blob individually 100 million times. So convenient. Now, all of those APIs, there are REST APIs for all of those. You can go look up the documentation. However, most people will just use our client libraries, right? We don't want you to have to go do all the work of chunking stuff into blocks and uploading them, parallel uploads, all of that. We take care of all of that for you in our client libraries. The source code for every one of our client libraries is on GitHub. So if you have customized things that you need to go build, you can take our source code, get started from there. Let's talk about two topics a little bit more detail. One is versioning, and the other one is leases and locks. So in our world, versions are called snapshots, right? So you have blob snapshots. And you can go ahead and create a blob snapshot at any time. It creates a read-only copy of a blob at that point in time. It'll have the same name as your blob with a time suffix appended. You can list all your snapshots. You can read them, copy them, delete them. So again, you use that copy blob API to make a new writable blob. So if you need to restore a version, but you need a copy of it, just call copy blob, give us the new name, give us the snapshot name from the old blob, and we'll create it for you. You can restore a blob with copy blob. If you give us the same name as the name from which the snapshot is coming, we'll just write over that and give you back your snapshot. And normal copy blobs don't copy snapshots, so that's something you have to keep in mind. And blob deletion requires you to delete all snapshots, which we give you a convenience feature, but that's something to know. If you normally try to delete blobs and it has snapshots, we'll correctly block and say, hey, are you sure you have a bunch of versions here? Do you want to get rid of all of them together? Right? So versioning is great if you're trying to do any kind of app consistent, let's say at app upgrade time, you're trying to say, I want to make a snapshot, make sure, I can go back to it if I have an application bug that I need to, revert from. Another common topic that comes up with object storage is concurrency. How do I manage concurrency when many different writers are trying to work with the same blobs? We have three forms of concurrency: optimistic, pessimistic, and of course, last writer wins, which isn't really a concurrency strategy. You just let whichever person writes last win. So let's look at optimistic and pessimistic. Optimistic is something interesting because it allows you to be more aggressive than just acquiring. Pessimistic concurrency is basically locking, right? Optimistic concurrency is lock only if you need to, right? And we provide that in two ways: timestamp based and e-tag based. This is where that standard metadata comes back in. You can say, don't bother updating this blob if it has been unmodified since the last time I wrote to it, which means no other writer wrote to it. Or you can also do the same thing with e-tag. If my e-tag matches, I don't need to update it, right? If my e-tag doesn't match, then maybe I need to update it. So that gives you that ability, and going the reverse gives you the ability to say, is somebody else messing with my blob? If I'm in an application thread, is something else also writing to the blobs I'm working with? And this is enabled in the form of conditional updates to our REST API. So these conditions are met, not met, they'll fail the calls. So you can use that in your application code. Of course, we support pessimistic concurrency. We call our locks leases, but that's essentially the same concept. You can get exclusive access to a blob. You can get a time duration one, so if your application crashes, the lock is released, or you can get an infinite lock, which can still be broken with the storage key, but it's meant to be like, hey, I'm going to hold on to this blob as long as I need to. You can change that lease ID, so if you have a workflow process, you can hand off that lease ID and change it, so you can have a blob go through a workflow. Very interesting in things like media workflows, where you have long-running workflows on the same large blobs. Another neat thing about containers is you can acquire them on containers to prevent container deletion. So let's say you're doing a large batch process and you want to make sure nobody wipes the container out from under you while you're chunking through all the blobs in there. You can go ahead and acquire a lease on the container and say, don't delete this container while I'm processing through this set of blobs in there. So very, very useful. As I said, last writer wins. I put it up there, not a concurrency strategy. So this is well and good. It's sort of a dry overview of, yeah, all these features, that's cool. I can go back and check them out on, on my dev desktop or my solution. How does this all apply to somebody who's just trying to use blob storage for an IT scenario, right? Backup or DR or something like that. One of the neat things that we've done over the last few years as our platform has been out is worked with a very large array of storage companies building solutions on top of these core features. Specifically, versioning and concurrency, fast uploads, fast downloads are very relevant to hybrid tiered storage, to global file systems. If you're trying to do global sync and share across many offices across the globe with a central repository, all of these concepts have to exist and have to be used by our partners. So one of our partners that has gone and built a solution for global file sharing is a company called Panzura that has both hardware and software virtual appliances. In order to talk about how Panzura is relevant to a real enterprise, I'd again like to welcome Ken Danila, who's a manager of information systems at Woodard & Curran, and he'll talk to you about how they use blob storage. Thanks, Ken.
So I'd like to spend a little bit of time talking about how we did use Panzura and leveraged Azure storage to, improve project collaboration within our company. But first, I want to take you back to run through the history of the problem we were trying to solve and something that's plagued me my entire career as an IT manager at engineering companies. So I want to take you all the way back to 1995. I worked for a small engineering company in Boston. We primarily worked on designing for the Big Dig project there. We had problems at that time synchronizing base files, base data within our design team. And our massive file sizes at that time, over a megabyte apiece, were outstripping our collaborative technology, which was the floppy disk. So what would happen is we'd get in base files from the state or from other contractors on a floppy disk, and we'd go right down the line of all the designers, put it in the PC, update your base file, take it back out, pass it to the next. And we would do that over and over and over again, day after day. So we thought, what are we going to do? Let's build a LAN. So we networked this workstations together. I knew how to use Lantastic, which I thought was the best named IT product at that time. We doubled one as a file server. We consolidated our shared data there, and we solved our problem. We'd never have to think of our network again. So I'll push forward a little bit to 1997. Now we had 2 offices, one in Boston, one in New York. And we wanted our engineers in each location to be able to collaborate with the engineers in the other and work on the same drawing sets. So we thought, what are we going to do about that? We'll build a WAN. We put in a 56K frame relay. Now the engineers in each location could write to the other one. Problem solved. We would never have to think about our network again. A few months later, too slow. We couldn't work from New York. Engineers in New York couldn't work in Boston. Engineers in Boston couldn't work on data in New York. The files were just too large at that time to pull over. So what did we do? Threw bandwidth at it. Problem solved. Never have to think about it again. 1998, too slow. What are we going to do? We threw bandwidth at it. Problem solved. Never thinking about it again. 1999, still too slow. Added bandwidth. Problem solved. And we went on and on and on, year after year, trying to fight the same battle with the same solution. We kept adding bandwidth, and it was still, year after year, too slow. The technology for design was greatly outstripping our ability to throw bandwidth at the problem. So this has plagued us for almost 2 decades now. And if you look at the engineering company, the typical engineering company now, we've moved on to expensive private WAN connections, MPLS, Metro Ethernet. We have expensive WAN accelerators. We're serving large files, hundreds of megabytes. I've seen files, single files, that were over 2 gigabytes apiece. I'm not saying that that's the right way to do design, but I'm saying that's a way to do design, and we have to be sensitive to that. So I'm talking CAD, GIS, orthophotography, and we're serving those off of expensive NAS files. And the typical engineering problem is we can't collaborate across geographies. We're not working with real-time data, and we're spending time synchronizing files as people are pulling files off the WAN from far, working them on their desktop, and pushing them back to a remote file server and hoping they're not overwriting somebody else that did the exact same thing. It's still too slow. So I'll give you a little background on the company I work for, Woodard & Curran. We have 900 engineers, scientists, and operators, and company administrators. We work in 19 offices across the US. We do environmental engineering, civil engineering, and plant operations. We believe in a one-company philosophy. We believe in collaborating across geographies. We believe in hiring the right people, regardless of the location, and integrating them into successful project teams. We're struggling with the same problem as our industry, across our industry. We had an aging storage infrastructure. We had a single NAS appliance in every location that was creating silos of storage. We had an expensive MPLS WAN to try to serve data from office to office, and it was no longer meeting the company's needs. So we worked with Panzura to create a cloud integrated data center. So what the Panzura solution is we essentially, well, first of all, I didn't make this slide. It's obviously a marketing slide. As much as I'd love to have a London office, we don't have a London office, so we'll say that's Portland, Maine. And as much as we do have a New York office, and as much as I'd like to say we have a Sydney office, we don't, so we'll call that our Atlanta location. So what we start with is putting a Panzura appliance in all of our locations. We front-end connect that to the LAN, and it serves files over a DFS share just like any other NAS. On the back end, we're connecting that same appliance to Azure Storage, our authoritative storage, and that's where we're storing our files permanently, and it's centralized. Meanwhile, all of those Panzuras are talking to each other continuously. So what we've done now is put it in a situation where every location can access the same data in real time by caching it locally and writing it back across the WAN to a centralized storage. So if I'm an engineer in New York, I can open my file off of the local controller. If it exists there partially or doesn't exist at all, it pulls down those blocks from the authoritative storage, Azure Blob storage, to that controller. It's been compressed, deduplicated, and encrypted. I'm opening it now off the LAN in real time. And the key to this is when I have it opened, it's now sent a lock to every other Panzura controller. No user in any other location can open that file without getting a lock error. Or essentially, they can open it. It's serving out over CIFS, so it just lets them know that I have that file locked. They can open it read-only, or they can wait till I release the lock. So now when I'm working on it, my reads and writes are going back at LAN speed. When I save it And when I save it, the lock is released everywhere, and the bytes are deduplicated, encrypted, compressed, and sent back to Azure. When that person in Portland opens it, now they are getting the changed blocks. Again, they do not have to re-download the entire file. If the file has been pre-cached previously in Portland, it's only picking out the delta changes that have been compressed, deduplicated, and encrypted, pulling it back to their controller, and now they're working at land speeds doing read and write. So this is how we resolve that issue. Additionally, Panzura is doing snapshots for DR. Those snapshots are stored in the clouds. They're not taking up space in the local controllers, so we can keep those controllers lean and mean using fiber disk to increase speed, and it's worked very, very well. And like I said, all the data on the controllers during the write to Azure and in Azure is fully encrypted. So we consolidated all of our project storage onto Panzura. We migrated all of our project data office by office into a single centralized location, which is managed by Windows DFS. Again, it's just a CIF server on the front end. The back end connection to Azure is what's doing all the magic. These local cache appliances allow for LAN speed and WAN files. When files are open, they're all locked across the location. There's no more need for manual synchronization. You know you're working on a file that is, you know you're working on a single copy of that file. So as far as the Azure storage side, we're using standard performance, geo-redundant storage. We're currently using it in the Classic portal, but as you saw, it's available in the Resource Manager portal, and we're looking to move that over now. And it's all connected to via the Panzura interface. When you're in the management interface for the Panzura product, that's where you put in your storage credentials, your encryption key, and then you just go. So the benefits we've seen are obviously improved collaboration. We have multi-geographic teams that are working at land speeds. We have a consolidated storage infrastructure. We replaced all of our NAS devices. We removed all of our WAN accelerators. We rebuilt our WAN. We pulled out all of our copper DS3 MPLS. We've replaced it with fiber direct internet access at all locations. We've doubled our WAN speeds. We saved about $250,000 a year doing that alone. We were able to move a lot of our other services, voice and video, to the cloud as well, which reduced our office-to-office data down to almost zero. And now we have predictable storage costs. We pay for what we use only. When we get to 90% utilization on a NAS, we no longer have to buy an expensive rack of SSDs that then stay mostly empty until they are finally full. We have improved our DR and business continuity. We have regular frequent snapshots. The Panzura system is FIPS 142 certified, and we have the reliability of secured Azure data centers. We can now secure our project data and our clients' data better through this system than we ever could have on our own. And we actually have no cloud lock-in. We initially implemented this on a competing cloud storage platform. When we started to build more and more compute and use more and more Azure resources, we decided to move this over. We worked with Panzura. They have a cloud-agnostic model to replicate our data from the other cloud provider onto Azure in real time with no downtime in the background. And then when it was fully replicated, we then just flipped over to use Azure as our primary storage and took down the other storage solution. Oh, now I'm into the next part. So thank you.
Thank you, Ken. Thank you. That was a great story in terms of sort of saying, how do we take all this technology that we've built and have, real usable solutions out of that, especially in that hybrid storage and global file system space. So this is a pretty common problem that we're trying to solve, where you have files that you want to store centrally. You want to have a global repository. You want it to be accessible from within the cloud as well as outside the cloud, many locations. You need that edge caching to have great local performance. You need global file locking, some of the stuff we talked about, concurrency and leases and things like that. You want better security. All of those things are things that we provide in partnership with our partners. Panzura is one of the partners that we have. We have a bunch of other partners in this space that we've built hybrid storage solutions with. So any of these partners, if you're interested, sort of describes a problem you're seeing in your environment today, one of these partners might be an interesting one for you to go talk to. Let's switch, again, gears a little bit and look at design patterns, and again, the real-world usage of some of those design patterns. So I'm going to go through a few patterns. The first one is data movement, right? I'm decided to use the cloud. The very first question is, how do I get my data in and out of the cloud? We provide a tool called AZ Copy that makes it super easy. It's like RoboCopy for the cloud. It comes with your Azure SDK. You can AZ Copy files in. You can download them. It supports Blob tables and files. And it does all the threading, the parallel uploads, the retries, the continuation, all of that for you. So it's just a little tool that you can go use. We have the library version of this, again, available on GitHub. So if you want to build that into your applications, if you need a custom application, you can go use the same code that underlies AZ Copy in your application. We also have partnerships with companies like Aspera and Signiant. And other data accelerator technologies. They're great partners of ours. Aspera's solutions work amazingly well with Azure Storage. So you can go ahead and have the UDP upload, the fast accelerated UDP uploads work on and off Azure Storage as well. Another interesting pattern is delegated authorization. Frequently, you have many users of your data, and you need to say, hey, you can't just use the storage key everywhere. How do I give restricted access? If I'm building a mobile application, I want the users to be able to upload data, but only their data, read only their data. We have this notion of what we call shared access signatures. There's a lot more detail on this in the security and encryption talk, but essentially, you can have a device, like an iOS device or an Android tablet, come up, talk to the storage service, talk to one of your services, a token issuer that has the key. You can issue a token that says, I only give you read access to this object for the next 5 minutes, right? I only give you the ability to write to this object for the next amount of time. Or I only allow you to upload and download over HTTPS, so I never have my data transiting over HTTP. So you can set all of these things. You can also use things like IP address ranges and IP subnets in the shared token, so you don't have data people accessing it from IP ranges you don't expect to. All of that can be encoded in a token and issued out. So it works great for accessing storage from untrusted devices. Another interesting topic there is encryption at rest, also covered in that security talk. But we do have server-side encryption where we encrypt data for you on the front ends, and we decrypt for you on the way out. So as your applications don't need to change, but your data is securely stored in an encrypted fashion. We provide this today with Microsoft Managed Keys for Blob storage. We're also working on an ability for you to bring your own key and have your encryption key, us do the encryption with your encryption key, where your encryption key is stored securely in our HSM as a service. It's called Azure Key Vault. So that's work that's in progress. We also provide application encryption for a number of industry areas. Server-side encryption, you need encryption right at the point of origination of the data, and we've made it easy by building libraries in .NET and Java to have client-side encryption working with your own keys on the source. So by the time we see it on our front end, it's already an encrypted stream of data. That's what Penzora is using, for instance. Another interesting pattern, okay, I've got all my data in. Now I want to index it and search it. Very common problem. You could stand up your own infrastructure with Lucene, with Solar, things like that. Works perfectly well with Blob storage. But we also have this as a platform service, the Azure Search Service. You can spin it up as a platform service, point it to your Blob storage. It'll index all your data. There's a set of supported formats. But you can also set it to index only your metadata. More often than not, you're trying to find files. Right, your customers are trying to find files, your users are trying to find files, and you can just do that with the standard data file name and the like, or custom metadata that you can embed, and that's frequently a much smaller amount of data to index. So both of those are supported models. I have a link here that'll be in the deck when it's available, but Azure Search Service is the name of the service. And then let me spend a little bit of time talking about cloud tiered storage, which is the title of the talk, right? We talked a little bit about tiering from on-prem to the cloud with devices, with solutions like Penzora. But there's also this notion about tiering data within the cloud, right? You have hot data and cool data even within the cloud. You have the live application data that's super high scale that people kind of constantly read and write to. But a lot of data isn't like that. It's what we call active archive, right? When you need the data, you need it right away, but most of the time you're not going to read more than a small percentage of that data set, or you're only going to read the data set once in a long while, right? For those scenarios, we've added the cool tier. This service G8 in April of this year, and basically allows you, as we looked at the demo, that hot and cool tier choosing on the account. It's exactly the same API, exactly the same experience. You just set that tier to hot or cool, and you get all the same options, availability, usability, so you can have the same storage account. The difference is that we have a different pricing model. Because you're expecting to access the cool data much less, we give you a 60% cheaper price versus the hot data. The catch or the converse is that we charge you for the data reads and writes. So we're sort of saying, if you have a petabyte of data on us and you're only going to read 10 to 50 terabytes a month, which is not unusual in a typical backup type scenario, you're not restoring all that much, store that large volume of data for a much cheaper price overall and then pay per access to that data, right? So it works great for a set of workloads. You can switch the account tiers from hot to, so you can start with hot data, switch it to cool data when that data is cooled down, or you can go back from cool to hot, though you'll incur that read charge once. In the future, we're going to blend these two tiers of data into the same account type, where objects will be hot or cool, not accounts. So you'll just be able to say, I'm writing a bunch of files. I've noticed that after 2 weeks, nobody reads these files. So if the last modified is older than a month, cool this object down. It's not going to get touched anymore, most likely. So you'll be able to do those sorts of things. We will integrate that with our partners so they have that functionality as well. Now, this is a great pattern for backups and archives, right? Again, the practical real-world usability is backups and archives. So I'd like to call up Kurt, who's a senior manager at NetApp, to talk about their solution in this space.
Great. Thank you very much. Thank you. I'm Kurt Springman. I'm with NetApp. You probably know NetApp as a storage company. Done a lot of traditional on-prem storage solutions. We're now doing a lot of solutions with Azure. Talk today a little bit about a company called Seminole County Public Schools, based in Florida, one of the larger school districts in the Florida state. And they've got a good-sized IT environment, 11 people on staff that perform a number of functions. One of the big challenges was the cost and complexity and lack of flexibility around how they were doing their backups and restores. They implemented a strategy around doing quarterly test restores to an offsite facility up in New England. And it was very expensive for them to actually fly people up and to do these types of restores to demonstrate that they had a recovery and DR capabilities. So we were looking for some solutions. It was also very labor intensive to do any sort of a restore just for a single item. Basically, their process consisted of backups to tape, putting the tapes onto trucks, putting those tapes into caves for safe storing. Reverse the process, you retrieve the tape, put it on a truck, bring it back, mount it onto disk space or onto the tape drives, finding the capacity, doing a restore, and finding capacity in your systems. So, long process, fairly labor intensive, and certainly not very responsive. What NetApp has is a product called AltaVault. This is a product that you run on premises. It's either a virtual appliance or a hardware appliance, and it works with the existing backup software you're using. So this is not a backup software product. This is a tape archiving solution. So you continue to run your existing backup products. You just simply retarget them at the AltaVault device. AltaVault then compresses, encrypts, and deduplicates that data, storing it locally for some period of time based on the size of the AltaVault you have, and then immediately puts that data up into Azure, and it uses the standard Azure APIs, and you can use it either the traditional blob storage or the cool storage, or if you're in government, you can use the government systems. So very efficient in terms of getting the data archived immediately up into Azure. Now, to reverse the process, you simply bring the data back down into AltaVault. Now, if it's recent data, it's probably cached locally. If it's longer age data, it's going to come down off of Azure, and you reverse the process to restore the data. Now, you can also do it at a secondary site. So you can have AltaVault at your secondary facility. You simply pass over the keys into the AltaVault, and you can restore your data into your secondary site. Now, what's really interesting is if you don't want to have that secondary site, you want to pay for those features, but you want to be able to test your restores. You can actually do that in Azure. So AltaVault is available as a virtual appliance in Azure. You get it through the marketplace. You're going to pay for it only for that period of time you need to use it in Azure. Then you get your backup software, also pay as you go, and whatever resources you need to do that restore. So you pay for it for a day or two to do your restores. You're doing test restores. You can now do your tests weekly, monthly, quarterly, whenever you'd like, and you're only going to pay a few $100s for that, for the resources to do that. You can, of course, also do a full DR restore your virtual machines, et cetera, into Azure. So in this scenario, the customer was able to use AltaVault to dramatically reduce their costs, streamline their processes, and take advantage of both the hot and cool blob storage for their archiving needs. Quick onboarding. This process, you can download and install the virtual version of AltaVault in 7.5 minutes. Immediately create a backup job targeted at the AltaVault, start pushing data into Azure immediately. So there's no need to re-architect, reconfigure. Very, very efficient and quick process. In this case, the customer bought our 400, configured with 48 terabytes. It's under $50,000, so not a terribly expensive solution. They had tremendous cost savings compared to just simply the labor costs and the physical media costs and the transportation and storage costs over tape. They freed up essentially a resource to be able to go out and do proactive IT development work. So not only the cost savings, but also then the ability to really improve their operations. The deduplication reduced the cost of the storage in archiving, so they got efficiency there also. So AltaVault, really nice solution. As I mentioned, you can be up and running and putting data into Azure in about 30 minutes. So this is a very simple solution to try. We've got a 90-day trial for the product, and it's cost savings up to 90% in some cases. It's a really nice solution. Thank you very much for the time today.
Thank you, Kurt. Excellent. So that's another way in which you can see cloud storage and the tiered storage especially. The AltaVault device and the AltaVault team looked at cool storage. They had to change none of their code. It was just a testing and certification process to onboard and support cool storage. So this is a solution, again, in terms of backup and disaster recovery that has a lot of common themes. You have data backing up from the cloud, from different locations, backing up into Azure storage as a target, typically through a device. You can do disaster recovery to your primary, to the cloud, to a secondary region. And you can also use it as a way of migrating data into the cloud. We have a number of solutions in this space, again, with different set of partners. We work with the largest backup vendors like Veritas and Commvault to have direct connectors. We work with folks like NetApp to have those tiered target devices, if you will. So this is another set of solutions that you can go look at if these match your solutions that you're using today or that you would look at using. This is a great on-ramp to object storage as well. So with that, I kind of wrap up my talk. I hope we've given you a good flavor of both real-world developer scenarios as well as real-world implementation scenarios to bring and kind of have your data in this super highly scaled, highly available, highly durable storage tier that we've built. Having that hybrid story in a real way, not just sort of theoretically. Again, that we can do it without our rich partner ecosystem. So we encourage you, a number of those partners have booths in the expo as well, so you can go talk to them about this stuff. We're at the booth as well. I will stick around here for questions afterwards, so if any questions, happy to answer them. The last thing I'd like to call out, please fill out your evals, right? Those are very useful to us. The last thing that I'd call out is, if you have a solution that you're considering that you want to talk to our team, we have a number of people from our team on site this week. We have these 30-minute meeting slots. We'd love to come, have you come by our booth, take some time, go one-on-one, discuss those solutions. So I will have the sign-up sheet here. If that describes you, if you're like, hey, I have a complex problem, I kind of want to do this, either developer scenario, IT scenario, happy to spend that time and follow up offline after the conference as well as needed. So thank you again for your time. Really appreciate it. Hope you have a good rest of your conference.